We will now see two more important theorems in the geometry of the circle: angles of intersecting chords theorem and angles of intersecting secants theorem. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. Angles of intersecting chords theorem. This theorem states that the measure of an angle formed by two chords that intersect inside a circle is equal to the arithmetic mean of the measures of the two intercepted arcs. We will draw a circle and two intersecting chords. These chords form angle alpha and the two subtended arcs AB and CD. We now draw the chord AD to create a triangle. The measure of angle A is half the measure of its intercepted arc. The measure of angle D is half the measure of its intercepted arc. We know that the exterior angle of a triangle is the sum of the interior opposite angles. So alpha is angle A plus angle D. The proof is complete. Find the value of x. In the first diagram, let's apply the angles of intersecting chords theorem. X equals half the sum of the subtended arcs. X equals 92 degrees. In the second diagram, we apply the angles of intersecting chords theorem, but we now solve for x. X equals 20 degrees. In the third diagram, we draw the alpha angle since we want to use the intercepted arcs 50 degrees and 100 degrees. Alpha is 75 degrees. Alpha and x are supplementary angles, so they add up to 180 degrees. X equals 105 degrees. Angles outside the circle theorem. This theorem states that the measure of an angle whose vertex lies in the exterior of the circle, and each of whose sides intersect the circle in 2 points, is equal to half the difference of the angle measures of its larger and smaller intercepted arcs. We draw a circle. The segments AP and DP are secants because they intersect the circle in 2 points. Notice that the intercepted arcs are CB and AD. By drawing the segments DC and AB, we form the triangles ABP and DCP. The angle A must equal 1/2 the measure of arc BC. The angle B must equal 1/2 the measure of arc AD. The angle B is an exterior angle of the triangle PAB. So B is the sum of the opposite interior angles. Solving this equation for angle P yields the proof of this theorem. The measure of the angle P is 1/2 the difference of the measures of the intercepted arcs. Find the value of x. There are 3 types of angles that are outside a circle: an angle formed by 2 tangents, an angle formed by a tangent and a secant, and an angle formed by 2 secants. For these 3 types of angles that are outside a circle, the formula works the same way. In the first diagram, The measure of angle x and angle external to a circle and formed by 2 secants is equal to 1/2 the difference of the intercepted arcs. When subtracting, start with the larger arc. In the second diagram, the measure of angle x and angle external to a circle and formed by a tangent in the secant is equal to 1/2 the difference of the intercepted arcs. When subtracting, start with the larger arc. In the third diagram, the measure of angle x and angle external to a circle and formed by 2 tangents is equal to 1/2 the difference of the intercepted arcs. When subtracting, start with the larger arc.